Hello everyone. We are going to continue where we left off last week. Last week we actually talked about the introduction to science, where I told you that science deals with understanding the behavior of the natural world around us through observations and facts. But today's topic is actually how science approaches the physical world around us, and we'll be talking about scientific approach to knowledge. So this is actually what we'll do, and this unmarked checked boxes here we'll talk about this first distinction between a theory and the law, brief history of the scientific approach to knowledge that I actually know about, and simple applications of the scientific approach to knowledge. So if we begin with the scientific approach to knowledge, we'll have to talk about some terms, and these are the terms: hypothesis, experiment, observations, theory, and lastly scientific law. So firstly, what's an hypothesis? An hypothesis, a guess, an idea that is proposed for the sake of argument so that it can be tested to see if it might be true. So from this definition, it tells us that an hypothesis is a guess actually made by us so that it can be tested to see if it is true or not. So this is actually the first step to the scientific approach to knowledge. We scientists or as science students, we guess and make an hypothesis that the sun is actually blue. This is an hypothesis, I just guessed. But for this, I would actually think about testing it if the sun is really blue or not. So next on the list is actually experiment. So we would actually talk about the meaning of experiment. What's an experiment? An experiment, a procedure carried out to support, refute, validate a hypothesis. A scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact. So from this excerpt, from the definition, it tells us that an experiment is being done to actually know if our hypothesis is true or not. My hypothesis about the sun being blue, if I actually want to know if it is true or not, I would carry out an experiment to know if it is true or not, if it is valued, or to refute it. So it is also a procedure done to demonstrate a known fact. Not every experiment are done to confirm or validate something. Some are done just to demonstrate a known fact to students, like some experiment done in school, titration and more. We'll talk about that in course 2. So the next on the list is observation. So what's an observation? Observation, the active acquisition of information from a primary source. In science, observation can also involve the perception and recording of data via the use of scientific instruments. So an observation basically means collecting information during an experiment about what we can see. It doesn't actually necessarily have to be what we can see, what we can smell, the changes that happen, collecting information from the main source and recording it. It can be through the use of scientific instruments or not. Observation is essential in science, and very, very essential. Without observation, the scientific approach to knowledge will be incomplete. Scientists use observation to collect and record data, which enables them to construct and then test hypotheses and theories. Next on the list is actually a theory that I just talked about here. So the meaning of theory is this: a theory is a carefully thought out explanation for observations of the natural world. So what's a theory? A theory is actually a well detailed explanation about the data being collected during an experiment, what is being observed, a well constructed explanation, and that helps bring together many facts and hypotheses. See, a theory we now know tells us why the phenomenon happened. Let me say why the occurrence happened. So a theory tells us why it happens and it gives us an explanation. So this is an example of another definition of a theory. A science theory is a well substantiated explanation of some aspect of the natural world. Same thing about the well explained parts of some of the aspects of the natural world based on facts that have been confirmed through experiments. So before we actually arrived to a theory, we would make sure that the observations carried out during an experiment is actually valid. Is actually based on what we see during our experiments, not something outside. And this is a simple theory I actually accepted from the book Doubting Atomic Theory. I actually accepted the shortest one I could accept for you. Doubting Atomic Theory. It actually states that atoms can neither be created nor destroyed. What Dalton was saying was that the number of atoms in the beginning equals the number of atoms in the ending. For beginners that actually don't have knowledge of this would do it in the course. There's no need memorizing this. So Dalton gave an explanation then that the number of atoms in the beginning of a reaction equals the number of atoms in the ending of a reaction, that there is no atom lost or gained. Next up is actually the scientific law. So the definition or meaning of a scientific law is, I would read it here: a scientific laws or laws of science are statements based on repeated experiments or observations that predicts or describes a range of natural phenomena. So observation actually tells us or describes how it happens. It's a statement that experiments have been done over and over and over, and observations have been carried out on. So the scientific law is usually valid, extremely valid. Experiments, observations have been carried out, and it describes what happened, describes the phenomena. So that's all about scientific knowledge and scientific law. This is an example, Hooke's law. It states that the extension of an elastic material is directly proportional to the force applied, provided elastic limit is not exceeded. So in this definition, it is actually telling us how it happened. That if an elastic material is being dragged, the force the force is directly proportional to the extension. The more you apply force, the more the extension increases, provided a limit is not exceeded. For students that still don't have knowledge about this, there's no need memorizing this. We'll do this later in the course. So as you can see, this sentence here, it actually tells us how it happens, describes the phenomenon, and that's why I came up with this idea to tell you the major difference between a scientific theory and a scientific law. And from this image here, see that a scientific theory explains why the phenomenon occur, and the scientific law explains how the phenomenon occur. So about the history of the scientific approach to knowledge, we will talk about a Greek philosopher, Plato. For students who want to actually see his image, this is the image of Plato. So Plato actually didn't believe in the scientific approach to knowledge. He actually didn't believe in it. Throughout history, humans have approached knowledge about the physical world in different ways. For example, the Greek philosopher Plato thought that the best way to learn about reality was not through the senses but through reason. He believed that the physical world was an imperfect representation of the perfect one. What Plato actually believed was that true knowledge came to by thinking or reasoning about the perfect world, not by observing the real world around us. Yes, true knowledge came not through observing the real physical world, but reasoning about the ideal world, the perfect world, the transcendental world, the world beyond space and time. The scientific approach to knowledge, however, is opposite of Plato's. We all know it is opposite of Plato's. Plato didn't actually observe, he didn't make hypotheses, he just kept on. He made hypotheses by imagining about the perfect world, but he didn't observe, he didn't make experiments, he didn't do some other things. So from this image, the scientific approach to knowledge, however, is exactly opposite. Scientific knowledge is empirical, it is based on observation and experiments. Scientists observe and perform experiments on the physical world to learn about it. We all have knowledge about that now. Some observation and experiments are qualitative. Also, I would advise students that don't know about it to carry on. Are qualitative, noting or describing how the process occurs. So this is a way of actually collecting data that we have observed. Is here by actually noting how the process occurs, or quantitative, measuring the changes of about the process of something about the process. For example, Antoine Lavoisier, a French scientist, a French chemist who studied burning, made carefully that the mass of an object before and after in a closed system, he noticed that there was no change of the total mass when he burnt it in a closed container. So what Lavoisier did here was that he made an observation about the physical world, a really important observation about the physical world, that when he burnt a particular object, a particular mass of a given object, he noticed that the same mass before and after were equal. So he observed during his experiment. So that's how science approaches the knowledge of the physical world. So please, I advise you to subscribe to the YouTube channel, like our videos, share, follow us on our social media platforms, and I actually added a video for you guys to watch, and this is it. And I also created a short clip for you guys to watch. It's more like a summary about it, where the cursor is Introduction to Science 002. I would actually give it a new name about scientific approach to knowledge.